All right. Well, I'd like to welcome you all to my talk today. It's going to be on problems with non-naturalistic theories. Now, I've been very interested in intelligent design and such for a while because I'm very interested in alternatives to naturalism. And part of what got me interested is that there are no really good critiques against things like intelligent design. I was ambivalent for a while, and I kept reading up on why people had problems with intelligent design, but after a while I realized none of it was very good, and so that actually made me more interested in intelligent design. But I'm also very curious in good critiques of intelligent design, because I don't see any of those usually. So here's my best shot at critiquing intelligent design. Now these critiques, they are of two kinds. There is one that's kind of just problems doing research using non-naturalistic theories. But then the other side is if a non-naturalistic theory like intelligent design is true, it's pretty disruptive to how we tend to think about the world. And so those are kind of problems. They're, I guess, cognitive dissonance problems. And so I'll talk about a couple of them. I don't quite have 99. It's more like 14 or 13, but close margin of error. Okay, so the first one, and a couple of people touched on this in previous talks, like Salvador and Tom Gilson, is the problem of supernatural causes within science. Now, a lot of ID proponents think that ID is a good explanation for things, but still would not actually say it's a scientific theory. However, ID has mostly advertised as a scientific theory. So that's why it's been pushed as being something you could teach in a scientific classroom instead of in a philosophy class. But one problem with saying it's a scientific theory is that normally when we talk about intelligent design, we're talking about God being the designer or some kind of unembodied cause. However, sciences today are empirical. We don't really have a good understanding of doing empirical science with non-material causes. Even when you get down to visible things like particles and stuff, they're still material in some sense, or energy or something. And also, the ID argument tends to proceed from an analogy with embodied intelligent agents, humans. Like, this is how Stephen Mayer argues for intelligent design. He says, whenever we see high amounts of information, we see intelligent designers, aka humans. And so therefore, when we see high amounts of information in biological history, we should assume an intelligent agent. Now, this only works if humans are indeed intelligent agents. And if they are intelligent agents, then we should be able to apply theories like intelligent design to humans. And so that is one deficiency I see in, I'm going to mostly talk about intelligent design because that's the main naturalistic theory out there that I know of that's really well worked out as far as they go. So yeah, intelligent design does not focus at all on using its methods to detect whether humans are intelligent agents or not. But if humans are intelligent agents, you should be able to do that. And that would get us a lot more traction, because one of the main critiques of intelligent design is that, hey, you can't really test God. So if you can't test God, why not test humans? Seems like a natural step, but for some reason that's not really done. I'm not really sure why. So my main point is that if we are going to have non-naturalistic philosophies of science, we need to start with embodied causes, such as humans, and then it'll make it easier to make that extrapolation to unembodied causes like God or other supernatural agents. And this point, I spent a long time on it because it kind of undergirds most of the other points I make later on. Okay, the second point is active information creation. This point requires a bit of background in ID theory, but it's based on a paper by Dr. Dembski and Dr. Marks and Dr. Ewart, where they show that in a search process, if your search is going to find a target any better than just random sampling, it needs something called active information, which gives the search process information about where the target is in the landscape. And this is not just a theory they've come up with. It's a corollary of a widely established theory. I use the word theory, but really it's proof. I mean, it's not something that's controversial or really debatable, called the no free lunch theorem. And this was first formulated by a physicist named David Wolpert, who works for Santa Fe Institute of Complexity or something like that. And he proved that all, this is for a field of machine learning, but all machine learning algorithms are identical to each other in terms of performance. That's a very counterintuitive claim, but it's claim made when you average all algorithms across all problem domains. When you do that, all algorithms are identical in their performance. There is no general best algorithm, which also means they're all identical to random searches across all problem domains. So the question is, where does active information come from then? Because it's very improbable that a search process then will perform any better than random sampling. And if it does, active information was the cause. But if active information is the cause and algorithms cannot produce active information, then where does it come from? That's a really big question. Intelligent design just says it comes from intelligent agency. And that's a fair point because we don't have a algorithmic or naturalistic explanation for it. But it also would help to be able to describe this kind of intelligent cause. What does it look like to create active information? If we have a time sequence of events, what does it look like in your time sequence at point A when there's no active information, and then that transition to point B where there is active information? What does that look like? And how do we describe this cause? Because it's totally unlike anything else we investigate with the sciences, since everything we investigate scientifically can be described mathematically and hence cannot create active information. Okay, now I'm going to focus more particularly with ID and the primary ID metric, complex specified information. So when something's intelligently designed, or actually the reverse, if something has complex specified information, it's intelligently designed. You can only get true positives and not true negatives, so you can't go the other way and say if it's intelligently designed, it has complex specified information. And it's a very good metric. It's very, I mean, in and of itself, there is no problem with it. But it's also hard to use in practice. So it's good in theory, but in practice it's difficult to use. Non-naturalism. Oh, okay, I have a quick question here. Is non-naturalism equated with ID? The two are not identical. ID is a specific formulation of non-naturalism, so it's kind of a subset. But non-naturalism is a more general category. I don't know if I touched on. I know Jonathan Bartlett, in one of his talks, deals with the more general question of what is the difference between non-naturalism and naturalism. But ID is a form of non-naturalism, and it exhibits a lot of these problems that I'm bringing up. But they also will probably apply to many other non-naturalistic theories. So for instance, with complex specified information, one of the big difficulties is calculating complexity. What is complexity? Well, you're looking at a particular artifact and you're trying to determine if it's intelligently designed. To do that, you have to first figure out what are the odds of this artifact coming about through naturalistic causes. And that's the complexity. And complexity is kind of another word for chance or randomness. What are the odds of this artifact coming about through purely probabilistic causes? And if it has a very high complexity, then it has no chance of, or very, very small chance of coming about through naturalistic causes. Now, here you probably see the difficulty is how do we account for all the naturalistic causes that could bring a certain artifact about? In one sense, it's easy with common sense. You see the word help written on a sandy beach somewhere, and common sense tells us there aren't really any natural causes that could write the word help on a sandy beach on an abandoned island. But characterizing this scientifically tends to be pretty difficult. But that's something we have to do too in order to make it a scientifically tractable theory. Next, we deal with the second part of complex specified information, which is the specification. So in order for a specification for your artifact is a pattern that describes the artifact. So there are two ways to talk about, say, your computer in front of you. You can describe it in terms of all the molecules and particles that compose the computer, and that would be a way of talking about its complexity. So you have like 10 gajillion molecules, and they all form a certain configuration. And so your complexity would be something like a count of how many molecules and how many different states they can take. Your specification is the particular pattern that those molecules exhibit, and that particular pattern is your computer. So that would be one way of specifying it. Some kind of silicon and metal device that is capable of processing symbols and interacting with an external agent. But the key thing about specification is that it has to be independent from the artifact. You can't just say, look at an artifact and say it is what it is, and that's the specification. You have to be able to describe it in terms that are not dependent on that artifact. So you have to establish independence for your specification. And there's not really any clear way of doing that right now. This is a critique of ID and not non-naturalism in general. I'm focusing on ID, but I would say that a lot of these critiques, like for example, the first one dealing with disembodied versus embodied causes, that would be addressed to all non-naturalistic theories. And ID happens to be the most clearly worked out non-naturalistic theory I know of, so it's easy to focus on specifics with ID and make a broader point about non-naturalism. So, but a non-naturalistic theory would also, it would have to come up with some kind of metric, and you'd have to still be able to establish independence when you're measuring something. So, yeah, you'll still run into these same kind of issues, making your metric scientifically tractable. So now, the final point I'm going to make with CSI is your specification cannot be subjective. In ID literature, especially the early stuff, specification was often talked about as being subjective. But then if it is subjective, you run into problems like confirmation bias and seeing patterns where there aren't any patterns and stuff like that. So how do you eliminate that problem, that issue, if your specification is subjective? If it's just a bunch of people agreeing that a particular pattern is a real pattern and not just something they've made up, you have to have some reason to trust their authority. And there's also a more general problem in that if your specification truly is subjective, then for any event, it's always going to have some specification out there. And if every event is specified, then no event is specified. It's like if everyone's special, no one's special. So you have to have some kind of objective formulation of specification that delimits your set of things that are actually specified. There are some good candidates out there. The best I know of is algorithmic complexity, and Dr. Ewert has formulated it into a new form, a new kind of complex specified information, which he has called algorithmic specified complexity. And I think it's a pretty good step in this direction of making it objective. Okay, and then here's an interesting point. If you know information theory, as invented by Claude Shannon, he didn't just make up theories, he used these theories to make a lot of money gambling in Vegas. And he was able to do that because the basic point is that if there's a true distribution for a probability function that generates events, and then there's the assumed distribution that everyone assumes generates the events, if there's a big distance between the two, then that's also worth a lot of money. So if we're right and the world is best described by non-naturalistic theory instead of a naturalistic one, there's a huge difference between those two distributions. And if there's a huge difference, it should also be worth a whole lot of money. And this is kind of the point that Salvador Cordova made in his discussion about how the NIH is making a huge wager on what is essentially an intelligent design-based theory. And there should be loads of those kinds of wagers out there. And of course, money talks. So if we're right, we should be able to also make loads of money. And then no one's going to care about academic debates and such, whether some scientists think ID is scientifically viable or not. If ID can directly make loads of money and non-naturalism and naturalism cannot, then who cares about academic debates? People are going to be trying to make money with ID. And that's what Arminius, I think, well, let's see, was it Cordova or Arminius? Someone pointed out that when physicists tried to apply their physical theories to the human market, it is very deficient. So that would be a good example of naturalism being way off of the true distribution. But we claim that we're right. We claim that we have the true distribution, so we should go out there and use it to make lots of money. Okay, now here's a tricky issue with describing what non-naturalism actually looks like. So whatever non-naturalistic theory we come up with, it can't be deterministic and it cannot be stochastic. It has to be a new third category. Because if any of our non-naturalistic theories can be reduced to some form of determinism or stochasticity or some hybrid of the two, then it ultimately reduces down to some kind of naturalism. Because all naturalistic theories can be described using some kind of mathematical formulae. And thus, naturalism is kind of identical to mathematical descriptions of the world. It's not entirely the same because there is a way you can mathematically describe things that are both non-deterministic and non-random, but that's really what we have to do. ID is a really good, that's the important thing about ID is that it is such a thing. It is a mathematical description of something that could not be deterministic and cannot be stochastic by definition. But that is something that really needs a lot more work, really fleshing out what causes that are both non-deterministic and non-stochastic actually look like in reality. And we have to do it with mathematical rigor. We can't just say this is non-stochastic and non-deterministic. We have to say what that looks like. And that brings me to my 8th point, is here is one thing that is by definition non-deterministic and non-random. And we do know what it looks like to some degree, and that's a Turing oracle. So to explain this, we have to go back to my first point, or one of my first points about active information, and how the active information invalidates the no free lunch theorem, because the no free lunch theorem says that algorithms cannot create active information. So anything that can is therefore not bound by the no free lunch theorem. To go against the no free lunch theorem limits, we have to be able to compute something called Kolmogorov complexity. So in this slide, I'm going to go a little bit into the weeds with computer science theory, so sorry if I lose some of you. I can talk more about these points at the end during the Q&A session. But so here's a chain of logic here. In machine learning, which is a field of teaching computers to make predictions based off of the experience they've had in the past, there's something called Occam learning, which says that your best compression of what you've seen in the past leads to your best prediction about what happens in the future. So your most concise explanation of what has happened is also going to be your best explanation for what will happen in the future. But in general, you can't actually do this according to no free lunch theorem. You can't find your best compression. And there are other reasons too, like the halting problem. If you can find the best compression for something always, then you can also solve the halting problem, which is yet another thing that algorithms cannot do. And to compute the compression for something, you have to compute something called the Kolmogorov complexity, which is the ideal compression, and that's uncomputable. So if you're going to make predictions, you have to do something that's uncomputable that algorithms cannot do. However, if you have something called the Turing oracle, you can compute the Kolmogorov complexity. The Turing oracle is something that solves this other problem called the halting problem. So if you have a Turing oracle, then you can solve the halting problem. If you can solve the halting problem, you can compute Kolmogorov complexity, and if you can do that, you can make predictions and go against the no free lunch theorem. So, rounding up all of that long discussion, if you do have active information, if something is creating active information out there, then that means that Turing oracles are real. And Turing oracles inherently cannot be algorithms. There's some, and by not being algorithms, they're also non-naturalistic. So here we have one mathematical description of something that is non-naturalistic, which is not deterministic and not stochastic. All right, I know that's a lot. I'm probably losing a lot of people, but we'll move on. Okay. All right, so here's another interesting thing, and this is where I get into where non-naturalistic theories kind of violate our worldview, how we see the world. We tend to think that the second law of thermodynamics is non-negotiable. Everything follows the second law of thermodynamics. Eventually, everything is going to fall apart. But if we have a non-naturalistic cause, it also looks like we have the ability to reverse entropy. We have the ability to go against the second law of thermodynamics. And CSI, by definition, is such a thing, complex specified information. So to understand this, first let's define entropy. Entropy in general is basically just probability. It's the tendency of a system to move to highly probable states. And CSI by definition means you're moving to highly improbable states. You're generating events that cannot be generated by chance. They're very improbable. So therefore, the greater the amount of CSI that's being generated, the more you're going against entropy. And it's also interesting in that the amount of CSI, as your CSI grows, you're making something that's exponentially more improbable. With every bit of CSI, you double how improbable your event is. So if intelligent design is true, then something out there has an exponential ability to reverse entropy. And I don't know, that would send up a whole bunch of red flags for any physicist out there who believes that the second law of thermodynamics cannot be gone against. And along with that point, we're going to have loads of breaks in the causal chain. So if your physical causal chain is A goes to B goes to C, all these transitions are highly probable. But as we discussed, CSI is an instance of something that's highly improbable. And so by definition, and it's occurring more likely or more often than it should. So by definition, it's breaking this causal chain. So we have tons of breaks going on in our physical world if we have embodied intelligent agents. Because everything an embodied intelligent agent does that creates CSI breaks the causal chain. And they're intelligent agents, that's probably quite a regular occurrence. All right, so this leads to my point number 11. So we all know that something cannot come from nothing. If something happens, it came from something else. So since non-naturalism implies that the material causal chain is constantly being broken, something has to be breaking it. And by definition, this something cannot be material itself. So we have something immaterial breaking the material causal chain. And since it's immaterial and since it's something, it has to be real. So there's an immaterial reality if we have a non-naturalistic theory. Furthermore, if we do have a non-naturalistic theory, it can't just be restricted to one very narrow part of science or part of some discipline, because naturalism has infected pretty much everything. So likewise, if we have a non-naturalistic theory of the world, then it too will also impact everything. In a sense, it creates a whole new worldview. Because we already have a naturalistic worldview that governs much of how we think about the world, then a non-naturalistic worldview will pretty much upend that naturalistic worldview. So basically this is to say that if we do come up with a non-naturalistic theory, non-naturalistic methodology, then we should also look into how it applies to pretty much everything and not just one narrow field. So in more particularly, we should look at how intelligent design applies to much more than just biological history, as important as that is. And then finally, this is a huge mystery for non-naturalistic theories, is where do these non-natural causes come from? And because I'm focusing on intelligent design, I'm saying intelligent agents. But if we have a non-naturalistic theory, then we are implying that there are non-naturalistic causes that are active in the world. But if they don't come from the natural world, and they regularly rely on some kind of immaterial reality, and furthermore, these causes are themselves not eternal. Like, for example, if we're intelligent agents, we're not immortal and eternal. We at the very least have a beginning. So therefore, something has to be creating us, making us. And by definition, whatever this is can itself also not be material or natural. So if we have non-natural causes in the world, we have to have some kind of ultimate non-natural source. So we have to have some kind of ultimate immaterial creator. And so this is to point out that I know a number of people think we should stay away from like talk of the supernatural and things that could sound like they're gods and stuff like that when we talk about non-naturalism. But in my point of view, I think it's kind of unavoidable, because whenever you say there's a non-natural cause in the world and you're going to have to embody things to make it scientific, then you have to explain their origin, and the origin can itself not be natural. So this is kind of also an unavoidable problem with non-naturalistic theories. So with that, I'll open up the floor to questions and answers. Does anybody have any questions?
I have a question. Do you hear me?
Yes.
What is your definition of nature?
What is my definition of nature? Okay, that's a good question. That is something I kind of breezed over. Okay, so by naturalism, I'm kind of boiling everything down to physics. Everything ultimately has to be explained by physical law. If everything is ultimately explained by physical law, it's ultimately expressible by some kind of mathematical formula that, and also an algorithm. All mathematical formula, you can express them by algorithms, and so ultimately it can be reduced to some kind of Turing machine or algorithm. So that would be my definition of nature. I mean, people can say they are, but I don't really think it's a consistent position, because if you're non-reductionist, you're saying that things cannot be, there are some natural phenomena that cannot be reduced to Turing machines. So then there's something else. There's something that is not reducible to a Turing machine. You could call that nature, but it'd be difficult to explain its origin, because it has to come from something that's non-material. And so then, I mean, you could call the immaterial thing natural as well, but then at that point, everything's natural, so is anything natural? Okay, Rope has a good question. He says, I talked about specification as grounds for design. What do I think about teleology? Well, teleology proper would be an example of something that cannot be deterministic nor stochastic, because teleology by definition is something that's future-oriented, that's best described as something that's happening in the future. But if it's deterministic or stochastic and or a combination of those two, then you can entirely describe it by what's happened in the past. So teleology would be an example of something that is non-naturalistic. If you detect a true teleology, it by definition is not something that can come from the material natural world. So specification and design, those open the door to teleological explanations. Because the problem with teleology in the naturalistic worldview, as I said, if all you have is naturalism, there is actually no such thing as true teleology. all true teleology can be reduced to non-teleology. So the great thing about ID and specification and complex specified information is that it makes the very concept of teleology actually have substantial meaning. It's no longer something that by necessity has to be reduced to non-teleology. So you now have this third category that makes sense of teleological language. All right, so Arminius says, my presentation is full of substance, requires careful reading and understanding, very good thoughts. Give guidelines on how to navigate the world space of naturalism and non-naturalism. I think this is a comment. Arminius, did you have a question there? Or is that just a comment on it? Oh yeah, I'll make one final response to Rope. He's saying that specification is harder to connect to teleology and stuff. And yeah, the two are not quite connected, but I would say that teleology is one instance of specification. In order to have teleology, you have to have a specification, but I don't think specification is conversely always teleology. Okay, and David wants ideas about guidelines of navigating the space of non-naturalism and naturalism. Well, I think a very interesting route to go that lots of people haven't looked at yet is what does an embodied non-naturalistic cause look like? Like if we're to spell out mathematically on some kind of time series what naturalistic causes look like, then in that same series, what do non-naturalistic causes look like? And that would have lots of places you could apply it to if you figured that out. For example, you could probably use it to make money on the stock market and such. Yes, yeah, that's an important point, Rope. Yeah, the ID discussion has implications across many, many different areas. Philosophy, theology, even has economic implications and implications for computer games, how we design good computer games. All right, so that's it. I'm going to close things down. So thank you all for surviving that talk. Appreciate it.